What's up, what's up, what's up? Welcome back, everybody. How's it going? Today we are working on our QR code decoder. So, context, we've got a QR code decoder that works pretty well on, like, perfect images, right? Like, well, I shouldn't say pretty well. It kind of works. We can identify, like, the corners of the corners, using, like, the finder things. I can't remember what they're called. And we have, like, a way to, like, walk the grid of modules, and like on like a small QR code where there's the error correction isn't interfering too much. It works fine. And I want to start working towards trying to get something on real images. And so one of the first things that we have to do is we have to like find where the borders of this QR code are in the image. And the way that we're doing right now is we kind of scan horizontally and vertically, individually, and we look for like segments of like dark and light. Great. And we look for like this pattern of like 1 dark, 1 light, 3 dark, 1 light, 1 dark. And if we find that, then we have like a potential location for the finder. And then if we intersect the horizontal and vertical ones, we'll have like one good center of this guy. And then we do that for each finder. Great. So the first thing I look at is, say we have our camera or on our phone at a bar. The bar has some sort of like clever QR code thing where they've like etched it into wood or something. It's dark. My camera sucks, and so it's like kind of noisy. And now we've got all sorts of problems to deal with. Maybe there's like some shadows, right? That's kind of what I've constructed here. I've like kind of like faked that situation. So one is that our whites aren't perfectly white in some scenarios. Our darks aren't perfectly dark. And if we go pixel by pixel, we're going to hit like all of these noise patterns here. And we might not be able to just threshold on 0.5 brightness. That might not be reasonable. And so if we're trying to say like, we want to see if we get a run of light pixels, now we need to do something a little bit more intelligent. So the plan for today is to try to like go from this into like a clean black and white image. The corners of the modules don't have to be perfect, right? Like, you know, we're not going to turn this into a perfect square. But at the very least, it would be nice to be able to see a good black and white representation of this thing. Something I'm considering is that like in areas like this, you're going to have to do some sort of like local adjustment maybe, right? Like you can imagine a scenario where what is light and what is dark depends on like where on the image you are. So what I'm kind of picturing is that like we take an area, right? We say we're going to look right here right now, and maybe we apply some sort of like blur to that area effectively. So we can do something like, let's try to make it look not shit. Right? You want to blur it a little bit, maybe a little bit to get rid of the noise. Then you have like this histogram here that says like, okay, I've got like a dark section here and a light section here, right? You have like two peaks where you can kind of consider those two peaks darks and lights. What that means when we get into this like more interesting area of between like over a shadow is going to be a little bit more interesting, right? Because if we do that same thing here, hold on, filters, blur, Gaussian blur, drop it down a little bit. Right, like what is dark and what is light here is a little less clear, and so I don't really know like what we're gonna do here yet. So if I look at like lights, it's kind of like over here, lights over here, it's kind of in this section, darks is maybe deterministic. Anyways, so the plan is to try to kind of iterate over this thing in some way, apply maybe some blur, apply some form of histogram analysis to try to figure out, okay, like where are peaks in this image, right? Maybe we look at it denoise and we maybe try to find centers of these like tiny slivers here where we have like chunks of one color. Not really sure. We're going to look into it. And so plan is try to visualize this in some way. So I think we're going to want to like maybe make a little UI where we can do something similar to this, where we can like kind of drag a block, like maybe like draw a square and then see the histogram associated with that and like see how our algorithm is like finding the peaks of those sections. Maybe also like output the blurred image of that thing. We have to figure out like how to do that denoising, how to cluster our histogram into like buckets of white and dark, and then once we figure out what sections are white and dark, then we can basically say anything in the light category goes to full light, anything in the dark category goes to full dark, and we can render out a image according to that criteria. So step one is get a visualizer working, because this is going to be very important, and then we'll kind of move from there. We will move on from there. Okay, so I realized like right before stream, that I was going to copy paste our server from the clustering visualization stuff, and that was using Zig 012, and the rest of our QR code decoder project is in Zig 011. So I think what I'm going to do right now is I'm going to do the work for today in a new project, and then deal with the fallout off stream later. So I think we're just going to start a new project for today, and then tomorrow we'll merge them together. Okay, so Zig init executable. No, Zig. Is it not Zig init? Maybe? Yeah, there we go. We have a main and a root. I don't know what root is. This is new to me, but I guess we will see, because I've never initialized a project with Zig 012 before. But that's fine. And let's kind of just start by yoinking our HTTP server from over here. We don't need like the whole thing, but it's like a good starting point. So this guy has a lot of stuff that's like specific handling of whatever the fuck we were doing over there. I guess some of this is going to be relevant. We're still going to be wanting serving. We're still going to want to do our like run loop where we use poll to make sure that we like handle signals correctly. We're going to want to handle HTTP requests. Our HTTP request handler is probably going to be pretty similar. We're still going to look for maybe like somebody's going to ask for some files, and we're going to try to serve those files, like the resources, HTML, JavaScript, whatever. But our like API endpoints might be a little different. So anything related to this stuff is probably going to be unique. So we'll just delete anything in here. Copy file. This is probably going to be the same. Where we could embed resources. For now, I'm just not going to do that. I'm not going to worry about that. This stuff doesn't matter. This stuff doesn't matter. This stuff is all related to HTTP, so we need all that. TCP server root directory for where we're serving HTML from. We're going to need that. Okay. I think most of this is the same. Does the QR code spec offer a standard way of error correction or something? It does. And so on large, it's like quite mathy, so we haven't really got there yet. And on large QR codes, the error handling, they do this like kind of like transformation where you have you have your, say you were to like lay out your bits in this order, right? They do this thing where they kind of try to like they group things vertically like this, and so they do this like kind of like swapping of order where they iterate this way instead of this way in chunks, and then error correct on blocks this way. I think it's because like that might like space out the QR codes, space out the errors a little bit better. But it just means that like depending on the size and shit of your QR code, you kind of have to know like what the sizes of these chunks are to iterate like 1, 2, 3. You have to like skip however many. So haven't got there yet. So not dealing with big QR codes yet. Every time I move my face, a lot this camera quality degrades. Yeah, it is a bitrate thing. I think I'm capped at 6,000 bits per second, and my GPU, I just like set my GPU to do whatever the fuck it wants to do. So not great, but we will live. We'll live. You guys don't have to look at my pretty face that much, anyways. You know, maybe you just like the code. The code. That's what matters. Probably I'm not going to do... Well, we can keep this query parameter thing, like parser. We might end up needing it, so I'll just kind of leave that in there. This is specific to what we were doing before. This is specific to what we were doing before. Delete those. This is also specific. Here, so this stuff goes like this. And these guys go away. We don't need this. We don't need this. We don't need this. Any of this goes away. All of this. Okay. And then we have basically no URI purposes yet, but we'll have these later. So I think what we'll do is we'll kind of maybe just comment this out for now. And here we will just comment this out and serve files unconditionally. That's how we'll start. We'll start by just serving files from some directory. Okay. Okay, so let's make our main, and here we will go bye-bye, and here we'll say const server is equal to import server.zig. And let's just start by, what are our inputs here? We take some allocator. So we're going to say, const general purpose allocator is equal to std heap general purpose allocator with an empty config. We don't give a fuck. And then we say const, this is to be mutable so that we can say on exit, call deinitialize on this guy, and he'll complain a bunch if we forgot to free any memory. Then we can say, hey, I want some allocator, and I want to create a server with it. So say const allocator is equal to GPA allocator, boom. And let's make our server. So const server is equal to server init with our allocator. Our root www path right now we're just going to say is required. So we'll do this. And path comes from this is www root path. Okay. So here we'll just say we'll just call this HTML or something for now. I don't know. Res for resources. I don't really give a shit. We'll figure it out later. And the IP is going to be, we'll just serve on 0, 0, 0, 0. We'll serve on everything. I don't care. And on port 9999. And we have to try this, and then we, in a loop, do true server run. And he's going to sometimes exit on us if we get hit with interrupts. And the idea on our last project was, why is that not there? On the last project, we did something where we handled signals. Yes. When we hit Control C, we wanted to make sure that our signal handler flagged that in some way and told us when to quit. So we'll copy paste this as well. So we have some SIGINT caught, should quit, blah, blah, blah. And then down here in our main loop, we say, well, we shouldn't quit. Keep running. And then we have to register our signal handler as well, which we did like this. Boom. Okay. So if we did everything right, which we probably didn't, we should be able to touch res test HTML, or index, we should call it. Touch res index HTML. And if we start our thing and go to localhost 9999, we should see that thing in our browser. So zig build run. Let's just see what fucking happens. Surely he's gonna complain. Surely we didn't do it right. Maybe he's fine. No, he's not fine. I was excited for a second. Okay, main. This guy needs a little bit of a. Ignore the result of this guy. I don't care. Server needs to be a mutable variable. We need invalid IP address format. Maybe we're not allowed to serve on 0000. Maybe we need 127.0.0.1. Invalid IP address format. Oh, oops, this is expected to be a string, actually. This is supposed to be 127.0.0.1. Or 0000 for everything. There we go. Looks like it might be running. So maybe we can go to localhost 9999 and error handling request for the MIME type, but it does look like we probably got the index back. Okay, chillin'. So now if we go res index HTML, we can do a what is it? Doc type HTML. We have some head. I don't really care what's in it. And we have some body, and in our body, we say hello world. And then we run our server again, and we refresh, and we see our hello world. Chillin'. Okay, server up. Now, what are we gonna do here? I think what I was imagining was I want to be able to, at the very least, let's just start with selecting an area of the image and seeing the histogram associated with it. Let's start there. Or maybe just select the area of the image and draw the picture. Let's actually start there. I like that better. So we're going to have some sort of like image. So this is going to be like from, let's just say like, we'll just call this input image or something for now. That's going to come from the server. And I don't know if the image is supposed to be like, I think it's like this, closing tag immediately. And then we will call this output image. And we will, in our server, do I have any signal processing background? Not particularly. Like, I mean, I have done like, so I worked with security cameras for a bit, and they had this like built-in signal processor. But you like a big part of our job was to like tune their hardware parameters to like result in something that looked okay. You know, I took like I must have taken some form of signal processing course in university, but I don't really remember anything. So not a lot, but I'm sure we'll be able to figure it out. I am sure we will figure out something that doesn't suck that much. Self-closing tags like in XML aren't really a thing in HTML. Yeah, I did see something about that where it's like, it parses the slash, but it doesn't actually use it. But then like you could argue that like you can write the slash to indicate that you know that like the expectation is that it is self-closing, but really you just have to remember it's whatever. It's fine. I'm pretty sure like Prettier makes me do that, so I just do it by habit. Okay, refresh? No. Let's make a git ignore to ignore zig cache and zig out, because that's annoying when I do search for things. And let's go here. And I guess one of the first things we're going to have to do is open an image. So I guess we will pull in stbi image or stb image and stb image write, because we're going to need to both, if we're like cropping a section out, we're going to need to write out a PNG or something to serve to the web server. So we'll just kind of like yoink this guy into wherever the fuck we put it. QR binarizing here. Yoink this guy, and annoyingly, it would be nice if I could just reuse what I already had, but zig 12. I should have remembered before, but that's okay. I guess we'll just start. We won't really like build up the image abstraction, I guess. And let's do we'll make a C zig, and in here, I think I saw there's like some like zig documentation. There's some syntax to be like, hey, I want to like import this stuff, but then like pretend that that it's like still the root or something. Zig 012, is that different? It's just like different enough that it's not like instant to fix. Like the HTTP server is pretty different, but like then the big one that got me was like some of the standard library APIs changed, and non-const variables are now errors if they could be const. So it's just like it's just gonna take like, you know, half an hour or something to fix up. Let's see if we can look at what did it take last time. Last time it was yeah, everything understood OS moved, atomics changed, unmuted var is now an error, and then I had like a lot of changes in HTTP server. Enough that it's worth it. Where are there like keywords list? There's a keyword I'm supposed to use if I want to like import a bunch of C things and re-export them. Keyword reference. Here we go. I'll know it when I see it. Nope. Using namespace is the one. So here, if I want to do this, pub using namespace at cimport. This is exactly what I was looking for. Oh, that's funny. They have they have an example of using STB image right here. That's really funny. How do you feel about backseating? Can I brain dump some signal processing stuff for discussion? Okay, so my take in general is you can say what you want, but I don't have to read it. And if it's like fucking weird, I might ban you. It's like the extent. But like, yeah, you can dump what you want. I just won't promise that I'll read it because it might be a little bit too much for me to take in while I'm thinking about this stuff. Pretty sure using namespace is on its way out. Oh, really? I mean, I guess for now though, if they're saying this is how I'm supposed to, like, one might have a czig with all the C imports. I think that like makes sense because then you only have to call C import once. And so, like, I will do it this way, and if they change it, then they change it, and we'll live. Okay, so what do we need here? STB image, we need to define STB image implementation. Oopsies. This thing goes here. And then we have STB image write, so we need to do this one as well. Okay. And we need to include STB image write as well. And then in main, we can say const c is equal to import c zig. And we should be able to start working with the images. Brain dump, subtract a very blurred image of the blurred version of the image to remove shadows, blur a little bit to remove noise, run a line detector, PCA on that to get axes, rectify UFFT, get QR code resolution. All of that makes sense. I think that I was going to not do PCA. My thought was if my QR code, I don't know if you're coming at this from having made a QR code decoder before, or if you're just coming at this as like, this is what I would do to approach this problem. But I was kind of imagining that if I had like my finder codes here, here, and here, I'm pretty sure that the like super fucking naive solution of doing horizontal scan lines and vertical scan lines to find the codes, I think that that will still work no matter the orientation of the finders. And then I think that from there, I can just like draw this triangle and figure out what my axes are. I'm not really sure what like the FFT gives us here. I guess you're kind of saying that like the modules are going to have some sort of like expected frequency. And I can like kind of figure out the approximate module size based off of the like how high frequency or low frequency the FFT, like the FFT peaks are. I guess that'd be my guess. Subtract blurred version of the image to remove shadows. That's interesting. I hadn't thought about that, but that does make a lot of sense. That's a cool trick. We will see. We will see how we get there, where we end up. Okay, what was I doing? I was trying to see if I could load an image. And we were trying to write a little bit of a shitty visualizer that lets us drag select an area of the image and output it. That's the first test. So we should have, I think in our build.zig, we do have to say that we do want to link libc so that STB image will compile. All of this, the rest of this seems fine. Zig build. Does that work? Does that work? Looks okay. Oh, maybe not. We didn't wait for it to finish. I got distracted. What is it doing? Okay. So that built, but we don't really know if it actually tried to do anything. So we can run c dot, and then let's start with like an image load. STBI image load, image open. Basic usage. STBI load. Oops. This goes under c dot, and we say var image is equal to this. It's probably const image, and we say defer c STBI image free of the image. Okay. Const width or var width is an I32. This is height, and this is num channels. All of these I32s, and we're going to have a desired channels of 1. We only want grayscale. Here we will open, I think it's under QR decoder samples test. Oops. Oh, fuck. I hate it when I mistype. Because then in Vim, it just does some like wacky shit and you have to like get back. QR decoder samples test.png? No. April 29 test.png. That's what I wanted to look at. Cool. Yeah. Sick. So now we should have an image, and let's just start there and make sure that like it runs. We need to set the include path in our build zig. So we need to say, hey, you can find our headers, add include path at source. And it's probably a b.path source like this, I think. That's how you're supposed to do that. I think. No luck here, so what's going on here? Wait, so the fucking C import just doesn't fucking work anymore? Oh my god. Are you kidding me? Oh, might have to make a C source file with the defines. I don't think the auto translation works that well on files that also contains the implementation. Yeah, I can see that. Didn't I do that? What did I do last time? Maybe that is what I did. Source. I do have image impl.c, and then in here, I probably did something like... yes, I see. Okay, cool. Good eye, thanks. Oops. CD back, and then foreground, and then here it was exe add C source file, and we'll call this a C impl b.path C impl /source C impl. Yeah, there we go. Oh, hey, what's up, everybody? Lewis Pilford, thanks for the raid. For those of you who are just joining, we're on our path to trying to turn this picture into something that's black and white. And we are right now just setting up our like debug visualizers. The idea is that we're going to be able to like, you know, maybe like select part of an image and see the results of whatever signal processing that we're doing. But it is important, I believe, to be able to see what we're doing instead of just guessing. So we're just in the process of setting up our zig bindings to STB image to get like pictures in our process. Okay. So source C impl. So we can do a little bit of shuffling here. C zig. So we say, hey, these guys, could you include stb image.h and include this? Yep. Get rid of those quotes, and then we define our implementation. Define this guy. And define this guy. All right. So now in here, we just include these guys without the implementations defined. Let me try this again. He doesn't like... Oh, I was supposed to add a C source file, not a lazy path. So what the fuck is this guy? Add C source file, module C source file. He probably has a path and a flags. Okay. File and flags. So we just have to say dot files equal this. Nice. Let's try again. We try again. Okay, we're chilling. We're compiled. And so we should have this image here. And now what we want to do is, I guess we want to like feed that. I guess technically for our input image, we don't really need to load it and then serve it. We could just serve it as a file directly. So maybe we'll start there, and then we will do whatever we have to do for our output after. So let's copy this guy. Where is he? Samples, April 29 test. We will stick this just here. And then here, our index input image will just be, I already forgot, it was like April 29 test.png or something. So if we run this, do we see our input? Here. We see nothing. Oh, probably because in our server, we try to derive the MIME type from the extension, and we don't know this one yet. So just throw a little PNG, and it's probably like image PNG or something. I don't know. If it's wrong, we'll look it up. There we go. Okay. We have our test. Cool. So I want to be able to like draw a box on top of this thing. I'm kind of assuming that that's possible, but I haven't actually thought about it. So can I just like draw, like stick a canvas on top of this guy with the same size and then like draw boxes on click? Seems pretty reasonable. JavaScript image overlay. I just want to see if overlay render canvas on top of image. Blah, blah, blah. Yep, okay, blah, blah, blah. Set the, so this guy says, hey, make an image, get your canvas to be some size. Then we have some sort of like callbacks online on mouse move. Yep. What about, how do I like link them together? Can I like, how do I stick them on top of each other? Canvas. Oh, can I just add the image into the canvas? I can. I see. So I almost like copy paste I almost like hide the original image and then draw it into the canvas after. Canvas MDN. Let's see. Draw image. Where's my API docs? Canvas API. Dude. Context ID. This is what I'm looking for. Draw image. Okay. So where does image come from? An element to draw into the context. The specification permits any canvas image source, specifically an HTML image element, an SVG image element, HTML video element, blah, blah, blah. So I guess probably what I'm supposed to do is like stick an image element somewhere, read from it and draw on top, like like am I supposed to like stick this in some sort of like hidden element? Is there an example? Here we go. So he gets an image. Yeah, so that's exactly what he did. He hides this guy behind some hidden div, gets the image, and then once the image is loaded, then we can figure out the size of it. Okay, yeah, makes sense. Let's do that, because I want to draw on top. Let's get a second instance open so that we can like edit our HTML live on the fly. All right. So this is like input image canvas, and our source goes back to April 29 test.png. We don't specify our width and height. And then we are going to say, hey, we have like some JavaScript run. Yup. And it's, what am I supposed to write? Like defer equals true or something to get it running after the rest of my shit? I think. And then I have to do this, I think. ID image source. Okay. So let's get our JavaScript going, and we do some sort of like window on load is equal to init, and we have async function init, and we say what? Image on load. We do something. Set up canvas, I guess. So I guess this just is this. And then here we say function set up canvas. And here we'll just start by looking at the image source and logging it. Let's just see what happens. Set up canvas. There we go. Okay, let's just see if that does something. Refresh. Console? Refresh? No? Error. Unknown MIME type for output image. Oh, do I have to write like... Let's try that again. Okay. So now what's happening? We have some... Refresh? That's not happening? Refresh? Refresh? Oh, here. We are here. Play. Am I in an exception? What the fuck is going on? I don't know what, like, what does this yellow mean in here? It means that run, I guess? Ran, I guess? It means that run. That's English. What's happening? What's happening? You can tell that I'm, like, super lost. Oh, I guess maybe the page never loads, never finishes loading because output image.png isn't, like, defined right now. Yep, there we go. Right, and then it's just like, of course it's undefined because it just says image. I'm a fucking dumb. So here we want const image is equal to document get element by ID image source. Boom. Okay. Refresh. Chillin'. Did we get our little log? Refresh. No. Refresh. Play. Refresh. Play. Is it not loading because it's hidden or something? Maybe I have to write add event listener. Maybe instead of on load. I would have expected that to work. Let's at the very least try unhiding this guy. So he's there. Oi, oi, oi. So let's try doing whatever the fuck they did here. Add event listener. Load. And then here we do set up canvas like this. Let's just see if that makes a difference. I wouldn't think that it would. I would have thought that onload was fine. Yeah, we're definitely... It feels like we are not getting to here. Is it because it's already loaded? Could be. Could be. Yeah, alright. We'll just do this then. Maybe it's... Yeah, it's fine. It's fine. It's fine. We will just do this. And assume. And make an ass out of you and me. Okay, so here we look up our canvas. Const canvas is equal to document get element by ID. And then we can say that our canvas is input image canvas. That hopefully spelled correctly. We want our rendering context, which get context 2D. And then we say ctx draw image. And I guess we need to like see the image size. So let's start by like console log image client width. Which one of these is which? Client width, image, client height. And I guess we want to like resize our canvas to that size. So how do we do that? MDN canvas. Size. How do I like set the size? JavaScript canvas set size. This is fun. I'm having a lot of fun. canvas width is equal to the image width, and the height is equal to the client height. This goes here. Canvas, I have to spell it right. And then all we have to do is draw the image at 0, 0, and the width and the height. Fun fact, every element with ID specified makes a global variable in JavaScript, so technically you don't have to use get element by ID. That's crazy. How am I just hearing about that now? That feels insane. That's wild. Draw image. Okay. So, image dx dy. So I don't even have to specify the width and height. I just have to specify the element that I'm sourcing. Refresh. No luck. No luck. Why? 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 Okay, so this is fine. We have our rendering context is fine. Do I have to like stroke it after or something for it to actually apply? CTX draw image. Get element by ID. I feel like it should be doing something. Let's start by like making a red thing or something, just to like make sure that the canvas is working the way I expect it to. So we should be able to like pull in a fill rect example. Yeah, let's just do that. Okay, let's just see if that does anything. Play, refresh, play. It does kind of feel like it's not even filling a rectangle. Oh, because the width and height are 0. Probably because I pulled them from the image width and height, and it thinks that those are 0 too, so I was probably using the wrong... Oh, HTML image, get width and height. Jeez Louise. Image width, okay, so it's maybe just width and height, not client width and client height. Let's try that. Just to see, refresh. Okay, there we go. It's there, we did it. And now we have somewhere where we can play with. So we can do something like, let's start with like, we need to have like some sort of mouse handler, I guess. We're trying to draw a box. We're gonna want to do something like, we're gonna start unclicked, on mouse down, we set it to true, and we say like start position is equal to null, probably is good enough actually. Then we're gonna have to on release, set it to null again, and do something like current ROI. I guess we will see. On mouse down, we are going to set start pause equal to something related to the event. So let's start by console logging E. Let's just start there. No more breakpoint, please. Thank you. Console. And we have client X, client Y, and are these relative to the corners or what? If I click up here, it does seem to be relative to the page, huh? On mouse down event. JavaScript. What is it? Client X in viewport coordinates. Okay, so then I need to get relative to the top left. I need to know my position in viewport coordinates, which I'm sure exists. I just don't know what that is. So let's just take a little quick peeksies there. Surely we have like client left and client top. But these are 0. Ugh. So it's some shit like is there like some sort of like internal fucking padding here? I hate everything. What, like, surely, right? Like when I clicked, maybe I'm just getting a little crazy. Let's just start by e dot. Oh, is there offset x and offset y? Maybe that's a little nicer. Ah, yeah. No, so offset screen page. Is there one that's like relative to my parent element? X coordinate relative to the position of the padding edge of the target node. Oh yeah, okay. So how come those don't look like they're coming in at anything of value? Right? Like here. Why is this still 0, 0? Like, hello? Is it just cause like console log e offset x? Like, is it just not logging the right thing? Oh yeah, okay, so if I log them directly, that works fine. Why, when I inspect them, I don't understand why when I inspected the event, it showed something different. That's annoying. Good to know though. Okay. So all we have to do is set our start pause to like e offset x, e offset y on mouse down, and then on mouse move, we adjust. So we say, hey, I want my canvas, I want my context, and I want to draw a box. So we're gonna say, I guess here we'll do something like render, and this will do everything we were doing before. So we get the image, we set the canvas size according to the image size, and then we copy the image into the thing. And then before we do all this, though, we need to... oh yeah, that's fine. This fill rect will reset everything. So I think we're fine there. And then down here, we just call render like this. Boom, boom. We set up our shit. So we get the image. We only need the canvas here, I guess. Yep. And then now we can start doing the on mouse move, we just call render. Boom. After setting the end pause equals to e offset x and e offset y. Okay. Okay. So now we should have what we need to draw over the top of the image. So we can say if start pause is not equal null and end pause is not equal to null, we have a box to draw. So ctx draw rect. Yep. We can... Is it just rect, maybe? Fill rect, rect. Just rect. Just rect. So we start at start pause 0 and start pause 1, and our width is end pause 0 minus start pause 0 end pause 1 minus start pause 1. Okay. Let's see if that does anything. He doesn't like that. Draw rect. Draw rect is not a function. It's just rect. Right, of course. Of course. Okay, I don't know if that is doing anything. So can we at least console log start pause and end pause? Let's see if we're at least getting to somewhere where we think we're drawing. And we do. So it could be that we just have to set up our like stroke in some way. Oh, we probably have to do like ctx.stroke with this. There we go. Hey, that's not bad. And then on mouse up, we have to stop. Doing something. I guess it's just that we want to only set the end pause if the mouse is down. So we say e.mouse is down. Can we check from the event if the mouse is down? Buttons being pressed. Yeah, this is what I want. So if e buttons is equal to 1. There we go. All right, not bad. Got our little box. Boom, 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 boom. Okay. Good enough for me. Okay. So now we have a region that we can send over to our server. And we can do something like request sub image or something. Right? And here we have a function request sub image. And he's just going to call. Can we do something like this? ID is equal to output image output. And then this guy is going to say something. Const. I guess it's going to be that the output is equal to a document get element by ID image output. Yup. And from there, he's going to say, hey, could you set your source attribute to, image output, but with some query parameters that are start x is equal to start pause plus or dot 0. Yeah, this seems right. And start y is equal to start pause 1 and end x equals end pause 0 plus end y is equal to end pause 1. Okay. I think that's right. So here, what we should see is after we draw this, we see, hey, could I get some image output with these query parameters? And that looks fine to me. Chillin'. Okay. We are now at the part where we have some actual work to do. So our server, he needs to say, hey, some URLs are special. So we have like image output. You have a stray whitespace at the end of the first string literal. That's true. Good eye. Good eye. And I guess we can just leave all this stuff in because there's a good chance that we're going to need to get something else later. So we'll just say, hey, we are looking at image output, and this has some purpose, which is image output. And we are matching the beginning of this guy. And so when we handle our HTTP request, we are going to start by checking the purpose like we did before. If there is no special purpose he tries to like send a normal file response. Otherwise though, we are going to do something special. Which is first we're going to get the query params. And I guess it's going to be var iterator is query param iterator initialized with the request head target, who I believe will look for the first, he will find the question mark and do what he needs to do. And we'll say, while it.next, we have some query param. And let's just start by printing it. So we'll just say key equals value. So query param key and query param val. Let's just make sure that we're getting what we think we're getting here. Expected thing after thing. So it needs a comma here. And then here, I guess we need to, at the very least, like, respond empty. So I think it's like request respond. What are like the outputs? Content here and respond options. It has to be something as well. Respond options. Keep alive. False is the only thing I really care about in here, I think. Keep alive equals false. Okay. And then, is that it? Might be. Let's see. Okay, so he's still complaining about something. Error is ignored. Try. I would like to try, please. Okay, we're chilling. We refresh. We run. And we crashed. Because he gets a HTTP connection closing when we're trying to receive something, which is not the end of the world. We should just not crash in that case. So here we should say catch, and we can log it. Error receiving request. That's fine. Doesn't really matter. For now, we just don't want to crash in that scenario. We just ignore that one. Incompatible types. What is he complaining about? What the fuck? Incompatible types. Is this not how catches work in this language? Oh, it's in here I have to continue. Say, okay, we didn't get the thing we expected to get, but that's okay. We'll just go to the next iteration of the loop. That's all he wants. Okay. So now we're not crashing, and we are seeing our parameters come in, which means that we can start doing something with them. All right. All right. So what are we going to do? I guess we're going to try to, like, look at the image that we have. So let's just make a, we'll fix this later. We already have an image abstraction in our QR decoder, but we'll just make another one now. It's just width, use size, or I32, height, I32, and image is a bunch of U8s. And I guess technically we don't need height, we only need to store width. And I guess I can't import main from the server, so I have to go this way. So I'll say, hey, server has this thing called image, and we are going to store that image. And so here we need to pass the image in. Image equals image. Hey, sorry, I just got here using std.http or something else like that. Just std.http. Nothing crazy. Nothing crazy. So when we make our server now, we have to make the server after we get the image, and we just construct him with, I guess we'll say image is equal to image from 0 to width times height. And we have to, like, int cast this thing probably for it to work. And then the width is going to be width. Okay. Which should mean that here we should be able to create a new image. So we have our ROI. Well, we don't have it yet. Let's get the ROI. So we're going to say, what, like var TL is equal to, let's make like a point abstraction, I guess. Or rect. Yeah, we'll do that. ROI rect. He's going to have like a TLX is a I32, I guess. TLY, bottom right X and bottom right Y. And so now here we can like pull those things out. So we'll say var ROI is equal to a rect, an undefined rect. Is that how I want to do it? I think it is. Fix me, check if query param was provided. And then we just switch on our query param. So we say if the query param key is equal to start x. I guess for any key, we're expecting to be able to parse the value. So we'll say the value is stood format parse int. We're parsing the value from the query param. This might fail, in which case we will say catch, and we will stood error log an error invalid query param, and we will continue. And then we'll say ROI TLX is equal to val. And we just have to do a bunch of these. So this is now going to be start Y and TLY. Oops. Let's do there, like this. And then this is bottom right X and bottom right Y goes from end and end. Cool. Cool. And then we'll just double check that the rectangle's okay. So we say, hey, could you print anything and only print the ROI, please? What does that look like? Error. Parse int. Oh, because all of this parse int needs to be, he needs to say, hey, I want to be a I32, probably, and yep, and I want you to be from base 10, please. Please, sir, missing closing thing at 145. Oh, at here. Please write anything, but only sometimes. Okay. Refresh. Draw the box. Looks okay. All right. So what we're going to do is we are going to maybe make like an how do we want to do this? We are going to say extract, maybe we do like a ROI iterator. Yeah, I like that. Because we don't have like a contiguous chunk of memory, but we do have like contiguous rows. Like within each row, it should be a contiguous chunk. So we should be able to do something like, hey, I'm going to take it myself. And I'm going to create this ROI iterator. And he's going to have some sort of like next function who takes in self by pointer. And he's going to return a subslice of some data. But maybe he won't because maybe we're finished iterating. And now we are going to look. Sorry, I got distracted. Is that printing built into language, or does Zig have powerful enough introspection to write your own such printing? So there's kind of both. So you can write your own format handler that can, like, I think look at any text that you put in those squiggly brackets. So we wrote any, but there's also like a built-in one that basically says, let me walk this struct and like look at all of its fields and like recursively go down and print out what I need to print, which is pretty sick. The introspection in like the the reflection, I guess we should call it, in Zig is pretty sick. This guy has to be an image. And then here we are going to, I guess we'll go by row. And we will have to also keep the image. And I guess we'll just say image dot image indexed by row ID times image width. So we'll say const start is equal to this. And the end is just the start plus image width. And then here we can just go start to end like this. And then at the end of this, we have to increment row ID by 1. Image here is not valid. Everything here has to be behind self. Boom, boom, boom. Wow, wow, wow. Okay, and then we also have to do our like edge condition check, which is if the row ID times the image width is greater than the image length, we return null. Boom. And it's looking a lot like it's going to make a lot more sense for this width to be in usize, which is fine. And this is going to return a ROI_IT with image equals self and row ID equals 0. Boom. And then in main, when we construct our image, we have to int cast this to get it from an I32 to a usize. But then everything else might just work. I'm going to put a little std debug print hello world here just to make sure, like, I can't tell when the fucking server starts, which is kind of funny. Okay, let's try that. Yeah, okay, so we're running, chill. I guess we'll write, like, server starting or something. It's a little more reasonable. Okay, and then wherever we were, we want to iterate row by row and probably like paste those things into some buffer. So it's going to depend on the STBI image write implementation or API. So we're going to want to write some PNG. I don't really want to write it to like a file though. I want to write it to a buffer, which I guess is what these like write PNG to function is. I specify this writer function, and that is just going to like extend some buffer, and then I can serve that buffer. In fact, what's kind of interesting is I could actually write directly to the HTTP output buffer with that. That's kind of fun. Oh no, but I guess I need the data as a void star. Oh, wait a second. With stride in bytes, you might be able to do something clever here where instead of like you might be able to set the stride to the width of the image and then set the width to the ROI width. And then maybe this just like kind of like does what we want for free. That's kind of interesting. I should have checked that first. So I'll say const c is equal to import c zig. And that should give us access to things like stbi c, stbi write png to func. And we're going to have to take in some function png writer with some context, which I don't think we need. We can probably get away with a void pointer. How do you do that? Null here, I guess? Because void pointers in this language don't exist. They just have optional pointers, and that's fine. Our width is going to be ROI dot bottom right x minus ROI. I guess it makes more sense for a rectangle to just have the width and height function on them. Function width takes in rect self by value. I think I read somewhere that you're supposed to use by value so that the compiler can choose how it's faster. I've been doing a const pointer out of habit, but I think that I should be doing it this way. And we'll say self.brx minus self tlx. Yeah. And we do the same thing for height. And so we go back to here and we can say, let's do ROI width and ROI height. What is int comp here? Compression level, probably? Write PNG. Where do they tell us what comp means? you can configure it here with these global variables. So they're saying I should use like C stbi write PNG compression level. Write PNG to func. And then we take in the data, which is just going to be our self image. Uh-huh. Yup. Yup. And then the stride and bytes, we're going to say self image width. Get crazy with it. They do have a write PNG to mem. You are correct there. Except I don't see, like, I only ever see implementations of it. Which is, I guess they're kind of expecting, like, the formal API is write to function, and then we have to define, like, yeah, I guess. Okay, so we need to do something like const PNG writer is equal to some struct with a field f, because there's no inline functions in this language. And Zig build, surely this is going to be wrong. So he wants this. So this is a, what are the inputs of this guy? Func. Here we go. Where is this guy defined? Context data size. So here we should say context data size. And we'll call this f, boom. And this equals context. This equals data, and this equals size. Okay. So this expected const any opaque found const u8. So I need to turn this into a pointer. And this width needs to be a C int, so we int cast this guy. BTW comp is number of channels. Oh, I thought it was compression level. Good thing that you said that, or else I would have just done it wrong. Value of type C int ignored, so here I guess we will just write like const ret is equal to this, and if ret is equal to -1 is going to be my guess. Return 0 on failure and non-zero on success. Okay. So this is not equal to 0. Stood log error failed to write file and return something error invalid. I don't know. Error invalid data or something. Who fucking knows? Who knows? Okay, if you're saying comp, yeah, it is say comp channels, huh? So we should just write 1 here. Okay. Okay. So I guess our context is going to be our... Here's what we're going to do. We're going to make a response writer. Response writer. And this is going to be response request response streaming. And we need to provide some options, which I don't know what they are yet, but I'm sure they're important. Some of them are, one of them is going to be like the header that we want to use, which is going to be, okay, send buffer, content length, and respond options. Okay. So we need to create a send buffer, which we can just make as a, 4K sized thing like this. So here our send buffer is our send buffer. We will respond streaming wise. We don't need to set the content length, and we respond options now is equal to something else. And what goes in here? We need the version, blah, blah, blah. Keep alive false. extra headers. We need to set the content type. So here we want to do something like, we need to set a header. So it's name is equal to content type, maybe? I can't remember. We'll see. Value is going to be image PNG. And then here we are going to take in the response writer as our context. So wherever we wrote null here, we're going to write response writer. Then we are going to say const response writer is equal to a whatever the fuck type this is. So we need, this guy is a response. And he's equal to pointer cast, probably needs to be a line cast as well. And then we need to unwrap the optional. We'll call it W here because there's shadowing, but we'll deal with that later. Pointer cast must have a known results type. Does he not? Oh, maybe this is fine. Then we just say W write all data and size, right? Or data 0 to size, like this. And then if we catch, we need to say stood log error write failed, but we can't really do anything about it because there's no error API on this guy, so it's fine. I would have been shocked if that compiled, to be honest. That would have been crazy. Send buffer expected this, so this guy probably has to be var, because we're trying to change the shit inside of him. Expected error union type found response. Oh, so response streaming can't fail, which is surprising to me. Expected any type, any opaque found const response, so I guess this probably has to be var to make that cast work. Yep. Stood log error. I forgot to put my error argument like this. What's that align cast for? So I think that like pointers have an alignment and objects require pointers to have a specific alignment. So the align cast is to say like, hey, we don't know what the alignment of this pointer is going to be that came in, but we need it to be this. I've come across that enough times that like I'm just expecting that to happen, but it could be that Zig doesn't need it in this case, but I've seen it a lot of times. Almost there. Unable to resolve comp time value. Whoa, why? Oh, maybe this has to be intcast to go from cint to usize? Slice of single item pointer must have known bounds. Oh, so how do I cast this single element pointer, single element to multi-element? Zig, single, Zig, Googling Zig stuff never fucking works. It's probably in the standard library, and we'll say like pointer something, slice, pointer as slice, no. Zig, single to multi pointer. Just change star to star. Will it let me do that? Is that legal? Unknown length pointer to any opaque. Zig, any opaque pointer to slice. Here we go. Whoa, 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 whoa. Oh, I can just say, like, whatever the fuck I want here. So he's kind of saying, I can be like, hey, this is going to be this. Is that legal? Nope. Fuck. But I could maybe pointer cast it. Data U8 is going to be like a... this. Is that legal? Yeah, it looks like it did it. Okay, let's see what fucking happens. All right, so we did get a bunch of errors. Failed to write file. So what's going on there? What is going on there? This is coming here. So maybe we can at least print the return code. At least, let's see what all the hubbub is about. Oh! Oh, it's probably because the response is closing. Okay, hold on. Okay. Wait. I think that this is mostly fine. Response. I think, okay, hold on. We need to finish the request. Here, so we have to do something like a response writer dot end. And I think this is failable. Yep. Okay. No response data available. So what's happening here? So we get the headers. Okay, so some of these guys are working. Some of them are not. But we're close. So I'd be interested to know what is failing here. Failed to write file 1. So can we at least see in STBI image write? Write file. Write PNG. So where are the like return values? It doesn't really say, huh? Just says non-zero return. It could be that this trick isn't doing what we want it to do. This like stride as image width. It might just not work. It might require some alignment. Let's try reducing the amount of spam. So let's only request subimage on release. On mouse up. And this will be request subimage. At least to like reduce the bullshit, you know? Okay, that's good. Second one does not seem to run for some reason. But it looks like the first one is working. But it also looks like it doesn't know that it's complete. So there's probably... Oh, we are seeing failed to write file. Oh, I bet what's happening is sometimes the stride is going off the end or something. Okay, let's just not return an error here. And let's just see what happens in that case. Oh, oops, we have the server running twice again. Fucking annoying. So now the response at least finishes. We are seeing the top left corner kind of unconditionally. So this guy has to have the image pointer plus the initial offset. Top TLX plus ROI TLY times self times self image width. All right, let's see what happens there. We need some int casts. this, as usize int cast like this. Let's see how that goes. Refresh. Yeah, that's not bad. Look at that. That's kind of neat. Yeah, not bad at all. Although I'm realizing that we are now going to want to like work with this image, right? So we might actually want to go back to using our iterator. Oh, that's pretty funny. If I go reverse order, then everything gets fucked. We have to go top left to bottom right, which is kind of funny. Okay. So let's say that we've got like the bones of our debug utility done an hour and a half in. And let's try to start thinking about like, okay, so how would we start denoising this guy? And I think what makes sense here is probably we shouldn't, like, this STBI image write stride trick only works if we're directly feeding input to output, but that's not what we want to do, right? We want to do something more like image ROI. We want to use that iterator to fill a buffer. So we are going to do something like while ROI IT next, let's get a row, and we'll make a const output is equal to std array list of U8s, I guess. Well, I guess we can calculate the size immediately. We can do a self allocator dot alloc some U8s of the size ROI dot width times ROI dot height. Defer output dot self alloc free output. There we go. And for each row, we are just going to say output std mem copy. Is it just mem copy? Yeah, mem copy. The destination is going to be the output from where is it going to be from? We have to like track our index, I guess. Like this. And so our output's going to be from I times ROI dot width plus, I think that's it. And he's going to be copied from row, I think. And then defer I plus equals 1, boom. And then here, when we write our thing, we are going to use our own thing, which is the output pointer. We're not going to do this addition shit anymore. And our stride is going to be now ROI width as expected. And if that works, then we are pulling the image as expected, which is good. Here we're going to go int cast like this. Turn these guys into usizes. Len, no field name len instruct image. Where is that coming from? Okay, so we've got some incompatible types usize and I32. So ROI width, we need to as usize int cast this, which is annoying, but it is what it is. What else is it complaining about? Oh, 227. We need to. This guy needs to be a attempted allocation. U8 is not an indexable pointer at 227. Hello? Does this not return a slice? What is it where is this complaining about? Zig build. Type unate is not an indexable pointer at line 227. Hello? Oh, we have to dot this to yeah, right. Const start is equal to this, and end is equal to start plus this. Maybe we'll do a const width usize is equal to a usize that is int cast, just to avoid some of the type finagling, which makes that kind of cleaner. And then our output is going to be start to end. There we go. Let's try that. Close. And now our only issue is at 14, where this guy's saying, hey, if I'm greater than image length, there we go. Double image. Start no does not exist, so this is not supposed to be a self field. That's fine. And let's see if we still get something that looks okay. No. We are immediately crashing. Where? Memcopy arguments have non-equal lengths. Okay. So what's going on here? Can we do like a little GDB zig out bump? Zig out bin this guy. Break on here. Run. Refresh. Draw box. P start, P end, and then P row. Row length is 196. Interesting. So why is that? P row IT width. P row IT? No. Why is there no row IT in the current context? Up? Down. Down. Am I high? 231? There should definitely be a row IT. Info locals. Interesting. Oh, because the row width is, this is wrong. We need to store the width here. Right. And then the end of this guy is not the image width, it's self plus, this width. And then these guys should match up. Which means that, this guy needs to take in a width parameter. No. No, that's not how we'll do it. We are going to subslice this guy. Yes. So we're going to go from row, what is it? ROI TLX to ROI BRX. Yes. That should do it. But these need to be fucking incast. Fuck! X start is a usize that is intcast. ROI.TLX. X end. Bottom right. X start. X end. Please do it for me. Yep, okay, cool. Zig, build, run. Refresh. He crashed again. Why this time? Index out of bounds. Really? What's going on there? Oh, right. So, we need to count how many rows. Since we're going row by row of the image. This is stupid. This is not what I wanted. Let's, make our row iterator take in. This is supposed to take in our ROI. It's stupid that doesn't. And here he's going to take in the ROI as a rect. And here he's going to return the ROI here. Here he's going to do ROI as a rect. Everyone's happy. And then here we just have to adjust our start and ends. So here we'll say the start is the row ID times self.image.width plus ROI.topLeftY. If the start is outside the image bounds, return null. Otherwise, the end is the start plus self.ROI bottom width. Yep. And this has to also be... This is like row ID plus the top left Y. Oh, should we zig in here? You fucking know it. You know it. Okay, so we have the start. And now we have to say if the start is outside the image bounds, return null. But also, if the start is greater than... like the height of the thing. So, or the row ID is greater than self ROI height. There we go. And this probably should be less or greater than or equal to both of these guys. And here, this should probably be like this, and we should probably say if end is greater than this. Yeah. That seems right. And then down here, where we're using our ROI iterator, now we can just do our mem copy from the row directly. And that should make more sense. I think so. There's a good chance that this doesn't work, but we'll see. Fuck with these int casts, man. As usize int cast. As usize int cast. Zig build run. 15. Oh, yeah. As usize int cast. As usize int cast. All right. Okay, wait, that looks right. Nice. Nice. Okay, so now we have a buffer that we can play with. And what are we going to do with that buffer? I guess we can do something. I haven't really... We have to... Let's apply some form of blur. So for now, let's just do a box blur just to see if we can have some effect. So we're going to say this is the... I guess technically... I think this ROI iterator isn't exactly the right API, technically. Right? It would be nice if you could get like... If we could do like a kernel iteration in input image space, that would be nice, but I'm just going to skip that for now. And instead what we're going to do is we're going to call this the input... We're going to call this input ROI, or input... Yeah, we'll call this input ROI image or something. And then all these guys are going to say input ROI image. Here we go. And now what we're going to do is we are going to walk each section of the input ROI. So we're going to say like for x in 0 to the ROI width as usize int cast. Surely at this point it just makes more sense for these guys to be usizes, but we're locked in now. You know, we're never gonna fix it. And I guess we also have to walk height here. So this is gonna be height. We have XY. We are going to look at our input ROI image at x times ROI, or y times ROI width. Const ROI width US is equal to ROI width. We're just going to do it. We have to put bullet. ROI height usize. ROI height. Okay. Yep. So now we have the pixel. But we actually kind of want to look at like the pixels around it. So let's just say, let's start with pixel 1. Yep. Start with pixel 1. Then we can do like a 3x3 box blur. So for each of these axes, we're gonna reduce by 1 as well on the other side. And that will let us make sure that we can do like a 3x3 kernel without going out of bounds. Yep. We will start by, we need an output image. So we will do this. Const output is equal to this. ROI width US times ROI height US, boom. And here we're just going to say output at this value is equal to some average. So this is going to be like a U8. No, we need U16 because we might sum up to a number that's too big, and then we will divide it and then cast it out later. So we just say for input for, so we'll say for x minus y minus 1 to y plus 1. And we call this in y. And we do the same thing for x. We will average these things out. So average plus equals the input image this thing. So this is going to be in y and in x. And then at the end of this, we say average divide equal by 9, because we've done 3x3 kernel. So this thing is going to be this size now. We say output is equal to int cast average. I've been wanting to learn Zig. I've done at least 7% of the Ziglings exercises, but I've been hesitant to not understanding how they're handling async and concurrency stuff. Just not sure about it. Everything else about it seems to be what I want to be my next language. I would say, okay, so my experience with Zig so far, if you've written C, you'll get it very quickly. It's very similar. I wouldn't worry about, like, I mean, maybe if you want to learn it for async and concurrency, like, I guess that's what you want, but I will say that I don't think that async matters until you're at a very large scale. It's like kind of nice, but like also, this might be a hot take. Is writing an event loop that hard? Like maybe this is just me having written code for too long. But like epoll's not that bad, right? Right? Like man, epoll. Like, all you have to do to get like a scalable event loop is like wait on some file descriptors and then iterate the file descriptors, and then like if you want to like do something based off of which, like, you know, maybe you have some like TCP connection initializers and TCP data stream initializers, and you have to have like a hash map somewhere that maps file descriptor to like function. But is it really that bad? Do we really need these crazy abstractions on top? I guess like epoll's not cross-platform, but then there's like things like lib event, I think, that like kind of just abstract the epollness away, and then you can just use like function callbacks. I'm sure that there's a reason that what I'm saying is like they're wrong, but it just feels like, I don't know, man, writing to file descriptors doesn't seem that crazy. But you know, what's that thing all software engineers do where they're just like, oh yeah, that's easy, and then like 6 months later they're like, I'm still not done. You're like, you said it was easy. It's like, yeah, well, here we are. Okay, so we have some output, and I think that this should be a box blurred thing now. Let's see what happens if we run this. Okay, so looks like we crashed. So this was in free. Oh, it's because we double freed. Oops. Oopsies, double free, as you do. Okay, so it's really hard for me to tell if this box blur did anything, to be honest. Let's iterate. Can we like iterate this like 0 to 5? Like just do like 5 iterations of a box blur just to see if it's like just like fuck my shit up, you know? Oops. It doesn't look like it's working. I would expect to see much blurrier here. So... Oh, it's because I'm not using the output pointer? That would do it. If I'm just not showing the blurred image, I'm not showing the blurred image. Oh, there we go. That looks kind of blurry. Let's go, like, 10 iterations? Or maybe, like, 20? Let's just, like, really fuck my shit up. Yeah, that's definitely different than the input. Oops, I have to select top left to bottom right, or else my server crashes. Classic, as expected. That's interesting. And I can see why whoever was saying earlier that you subtract the blurred image to get rid of the shadow. It does seem like it does just make everything darker, eh? Let's just do like, again, let's just get crazy. I just want to see like a really fucking blurry image, you know? I want to be very certain. Why does it seem like more iterations is not like, I would think that this should like really fuck my shit up. Oh, because it's only ever looking at the input image. So what we have to do is we have to look at the output as we have to look at the output image here. And then here we initialize the output as a mem copy of the input. And then this should really fuck my shit up. Let's go back down to like 5. Okay. Refresh. Oh yeah, there it is. That's some really fucked up. Oh, hold on. I need to... No, this doesn't work. I can't use the output as an input directly. But what I can do is I can use the input image here, and then after all of this, after we're done the whole thing, we say mem copy from the output back to the input. And then we should see multiple blur passes. It's just turning black, which is kind of fucking weird. That's surprising to me. Can we just go back to like 1 iteration? How fucked is that? That's okay. Adam learns live. Rids with the party of 118. What is up, you guys? That's a lot of people. How's it going? We are working on a QR code decoder. So right now we're just trying to get from this like fucking noisy ass image to something that's like somewhat clean. We're trying to like binarize these things. So like we're hoping to get to the point where we can see black, white. Go from black, white. Right? Like this is not black or white. We want black, white. That is like essentially where we're at today. And we spent longer than I would have hoped building up this like visualizer, but it's kind of fun. We can like draw a box on here, crash my server, of course. But if the server didn't crash, we'd be able to draw a box and see like a blurred version of it. So that's what we're going for. I suspect that this like average divider is too large. This is what I like. This was supposed to be a 3x3 kernel. We were adding up all of the things in the ROI, but it's getting darker and darker with every iteration, which just like really indicates this is bugged. But I don't know why, because I feel like, oh, maybe this is supposed to be y+2 and x+2. That does look a lot like, if I want to go from 1 on either side, I have to go 2 passes my end. Okay, let's try that again. Let's try that again. So here, there we go. Look at that. There we go. That's a blurry thing in the region we selected. Look at that. And let's like just like crank up our iterations again. Let's just get crazy with it. Oh yeah, that's working. Hell yeah. Okay, so I just fucked up the averaging. You're arguing that I should do rounding instead of truncating as well, which is probably true. Yeah, you're probably right, because the integer division is just going to truncate. So I should do like average. It's not average plus 4 over 9, right? It's average plus 8, right? Because that will push. Is that true? No, it's not. You're right. It is plus. So here we have 0, 1 plus 9. Yeah. It goes to 10, which goes to 9. So we do want to add 5 or something to push us over the edge. 1, 4. Yeah. You're right. Average plus equals 4. Rounding. Shitty integer rounding. We don't have to get crazy. And that should preserve brightness a little better, although the major bug was something else. All right. Denoise. Done. But to some extent, right? We'll call it prototype mode. That's what I call it when we're just fucking up our shit. When we're just like, we're not writing good code, but we're just trying to see if the concepts work. So, there's a lot to like fix here. The fact that all of this is inlined in like one switch statement in our like HTTP handler, it's like this isn't where any of this belongs, but good enough for now. Okay, let's like reduce the blur level. We probably don't need 10 iterations. Like probably like 3 is probably good enough. Yeah, that feels pretty decent. We could maybe do maybe even like 1 less, to be honest. It doesn't need to be crazy. And really, like, later I would probably lean towards like a Gaussian blur or something as well, but this should be enough to get us going. And I think what I want to do next is I want to get a histogram of the selected region. And then we can use that to do some debugging. So I guess that kind of indicates that when somebody sets the ROI, we need to like store that information somewhere. So probably this is turning into something stateful. So let's like maybe pull out a something. I don't know what yet. Let's do like source. We'll just call it app for now because I don't want to think about it. And all of this stuff will just go in there somewhere. So our app must hold an image, who is going to be defined over there. Whoa. Let's before we start really fucking up everything, let's just make sure that we get in it. Git add source res, git status. Is everything in here what we want? Arm source root, we don't need that. But everything else I think is useful. Git add build zig, git add shell.nix. And let's just make sure that we have initial commit, because surely I'm going to hack this shit up and then regret that I didn't do it right. Okay, all of this stuff goes in app.zig. This image goes away. Instead of taking in an image, we're going to take in some sort of like app. And we're going to say like app is probably a like app reference, probably. And so we're going to have to do something like const app is equal to import app zig, like this, probably. I don't know. And then here we're going to say like app is equal to app. App, you know? And then down here, when we try to get the image output, what we're gonna do is we have to take this like ROI stuff, and in our app we're gonna store like an image, and maybe we'll call this like source image, and then we will have to store some sort of like output image as well. And we're gonna do something like set ROI. Yeah, that seems reasonable to me. And that's going to take in a rectangle. And probably, like, maybe it can error out, but we'll return void for the most part. And then all of this stuff is all fine. This is like HTTP parsing, HTTP response shit. this is the actual interesting part. So this is the guy who's creating the output. So all of this goes in here. So he's going to take in self as well, I guess. Who's going to say, I'm a pointer to a type called self, which we have to define. Const self is equal to app and this. And I guess we just have to start looking for what do we need to store in here. We need to store an allocator, which kind of means that we need that allocator type to exist. So const stud is equal to import standard library. And then we have some allocator, which is a stud heap mem allocator? Mem allocator. So it doesn't have to be on the heap necessarily. You know, it could be anywhere. And then just at the end of all of this output now goes to error defer, right? We might not free it. We will only free it if there's a problem, and then we'll just say self output image is equal to a image. He's going to have like some sort of image field, which is the pointer, or like the slice here, and we have to store our width, which is going to be the ROI width. Okay. So what we should be able to do here is if everything worked correctly, we should be able to say, hey, I want to set the ROI to this ROI. And then I just want to like look at the output image and serve it. So we should just be able to delete all of this stuff and use this stbi write function, but with something else. So this is going to be like self or self app output image pointer. I think that's probably it. And certainly in main, we're going to have to make our app. So var app is equal to app. We need to import the app type here. Const app is equal to import app zig. And then what are we doing with it? We're doing something. App dot. We have to maybe make an initializer. Who's going to take in an allocator and an input image. And he's going to return himself. Maybe he's going to error out. Is there actually anywhere where this can error? Yeah, there is. Because he tries to allocate shit. Of course. So what are we going to do? We're going to say like, const var ret is equal to, you know, he's got like an allocator, which is our allocator. He's got his source image, which is our input image, and we can just copy that. That's fine. And our output image, we're going to start as undefined. And then what we're going to do is we're going to call ret set ROI with the size of the image. Or maybe not. Maybe we'll just say, we'll make it really small. No, we'll make it really big. So the initial ROI is going to be something. The input image, we're going to have our top left X is going to be 0. Our top left Y is going to be 0. Our bottom right X is going to be input image width. Yep, and our bottom right Y is going to be the input image len over the input image width. There we go. Boom. And this is going to be try, and then we return ret. Which means that in main, we should be able to say init with our allocator and our this thing. Oops. An image with these parameters. And then here, instead of passing in the image, we just pass in our app. All right, let's see what happens. Certainly there's going to be a ton of builders. Zig build please. So expected type app found pointer, so that's a mistake. This guy wants to take in an app pointer. What else? Give it to me. I didn't write try on my app initializer, so he's an error union and he doesn't want to be an error union. We want to set the ROI, and there's no field named set ROI. in that thing, which is surprising to me. Oh, because this guy needs to be an app, probably. Probably doesn't know. Yep, and then there's a bunch of int casts here. Int cast. Int cast. Boom. Okay. And no field image in the struct app. Right, so self image now needs to be self input image everywhere because it's now ambiguous. Nothing called input. Oh, it's source image. Fuck me. Source image. Boom, 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 boom. Let's try that again. Oh, wait a second. These guys should still be image. I don't know. I'm high. This is in a different field. Different struct. Rect is not marked pub. We're getting closer. We're getting closer for sure. Pub. 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 Just everything pub, please. And set or not. Fuck. Fuck. I just want it to be pub. Maybe? Yeah, let's go. Zig, build, run. Is everything still working? Looks good. Okay. Now that we have this set ROI function, we can make a new, maybe we make like a new endpoint that is no longer image output, is no longer responsible for this. Maybe it is. I could make like a set ROI thing here, but we'll just make the image output because I don't want to change it right now. And then let's make a new thing that's called Histogram. And his purpose is going to be histogram. And his he is going to need to be an exact match, I think. I think that there's not going to be any query parameters on the histogram. Maybe. I don't think. And so now what we can do is we can say, hey, if we are asked for a histogram, we are going to ask our app, hey, could you give us a histogram? Who's going to be he's going to say, hey. And my histogram is going to be maybe some counts of number of elements at each pixel. I think that makes sense. So this is going to be 255 elements long. So I guess we can even maybe like hard code that. So this guy will return direct, like no heap allocation, and maybe that's fine. Our stack is like 8K, so 255 bytes isn't the end of the world. 255 times 8, still not the end of the world. And I guess we're gonna do something like we have some return element, which is 255 usizes, and they're all gonna start at 0. So you have to do like what you say, like 1 usize array times 255, and I think this creates the right thing. This one always tricks me up a little bit. And then we can say for, I guess we just look at the output image. So we say for self dot output image. We have some pixel, and we just say ret p plus equals 1. That was easy. That was easy. So then we say, let's look at the app histogram. I'm glad you're talking out loud with what your brain is thinking while you're writing these lines. Well, otherwise it'd be so fucking boring, right? If I was just saying, like, I try at least to not just type what I'm writing either. I try to say the higher level thing. I don't think I succeed at that all the time, but that's like kind of like the ideal. Because otherwise it's just like, if you were just watching me type, you would just leave, right? Like, it's just so fucking boring. But I hope that by saying the stuff out loud, that you can kind of brain off, follow along almost, is the hope. That's the hope. So we have some histogram that comes up with this guy, and we're gonna have to like serve this thing as JSON. So I think what we do is we say, hey, HTTP server, I would like to send some response. And I would like to use this backing buffer, send buffer. So we can actually put the send buffer up here. Fuck it. Say, hey, we want to put the stuff in that buffer, and we have some options. The content type is going to be application JSON. I think application JSON? Text JSON? Content types. JSON, MDN. There we go. Is there no list of them here? MIME types. Here we go. JSON. JSON? JSON. JSON. Why is it not in here? Maybe it's application JSON and text JavaScript. Application JSON. Yeah, okay. Application JSON. Which I might have spelt right. Maybe I didn't. But who fucking cares? We'll get mad later when I'm wrong. And I guess all we have to do here is write into this thing some JSON. So I guess there's the standard library JSON writer, which is maybe overkill here. But it's fine. We might as well use it. If it didn't exist, I would be fine with just using a normal, like just doing it by hand. But this is fine for now. Is this thing failable? No. So we just say var JSON writer is this, and we say, hey, we're just gonna like make some array, and we're gonna stop making some array at some point. And these things are both failable, I think, because the write API is failable. And then we're just gonna iterate over the elements of our histogram, which I think we flagged as failable, but there's no reason to do that. So we're just gonna go over elem like this, and we just say JSON writer write elem. Boom. And that might be good enough, to be honest. I think at the end here we have to say try response writer or response end, finish, request. What did I do down here? Response writer.end. Right. And I don't know if I have to like flush the JSON writer either. I don't think so. I think end array covers all the cleanup that I need, so I think this is probably fine. Probably fine. Okay, let's try running that. Certainly he doesn't compile. Why would he? No histogram in URI purpose. Okay, so we need to create that part. Histogram. Now what? Now what? He's such a whiner, this guy. Fine, we'll give you no options. Okay, and error is ignored. Fine. Fine. You're gonna be like that. Okay. So if we look at the histogram now, that is a histogram, which is kind of nice. Those numbers, you can see them go up and down just if you look at like number of digits. And then let's just double check too. If I like pick some subset, we should see this histogram change. And we do. Like the numbers are much smaller now, which is a really good sign. Fucking cool. And let's just double check. The histogram should be coming from the output image, which it is. Okay, we're chilling. So now we just need some way to like visualize that histogram. So I guess in our index, we say, hey, I have some... how do we want to render this thing? Probably an SVG. Well, okay, we have two options. SVG or Canvas. Which one do I prefer here? Canvas is fine. I think probably SVG is overkill. SVG is kind of nice if you want to like, you can like attach hover elements and stuff. Like if you like click on a bar in the bar graph, then like you could do something with that. But I don't think there's any reason to. Don't listen to me when I talk about web dev because I don't know shit. Right? But I'm gonna use a canvas. ID is equal to histogram. Yep. And let's maybe stick this in a div so that it's like below or something. And here, let's call this init images, and then that way we can reuse the names and not think about it. So in init, we can use init images, boom. And then what are we going to do? We are going to we're going to try to like get a histogram. Every time we request the sub image, we have to update the histogram. Seems reasonable to me. So render histogram. And in here, we're going to do something like, it turns out that this rename was unnecessary, so I'm just going to go back real quick. Init, delete, delete, delete. And here we'll say, hey, I have some canvas that's going to be the histogram canvas. I don't remember what I named it. It was histogram. Histogram. Let's just like give it a width and height. Hard code it. 400 by 100. I don't know. Maybe we'll do 400 by 400. Fuck it, you know? We can do what we want here. We're in charge. And so we'll get the histogram. We'll get the rendering context. Surely I've done that somewhere. And what we're going to do is we're going to say that we're going to get like some bar width, which is going to be 255 elements over the canvas width. Is that the right direction? Canvas width over 255. Because if the canvas width is 2, we want each of our bars to be 2 wide. Oh, sorry, if the canvas width is 500, we want each bar to be 2 wide. So this goes on top. And we say for I is 0 to 255. This was I. I guess really, yeah, it's fine. We're going to draw some bar. The bar width, actually, we need some bar padding as well if we want to see some distance between them. Do we care if we have like distance between them? We actually don't. It's actually totally fine for them to be like smushed up all the way against each other because we just care about like shape. So the shape will be fine. I guess we need to get the data. Huh? That seems important. So this is going to be an async function. And we're going to do something like fetch from histogram. And we want like the response to be this, then we want to do response.json to get the body. We have 256 values, not 255. It's a really good point. It's a really good point. And 255 is probably one of the most important ones. So let's just do a little grep for fuck. Good eye. 256, 256, 256. If only I had, you know, maybe made some sort of constant for this guy. But it's okay. You are right. You are right. Okay, so we're going to look at the data. So, and then we're going to, first we need to like find the maximum in here. So it's like math.max.apply null to data or something. Is that how you do this? Max val, let's see what this, and then we say the data at that value over the max val is going to be rendered to this bar. So ctx fill rect from I times bar width to start x is this I times bar width, and then the end x is, or I guess the width is probably what they want. And then the y is going to go from, is the fill rect top left? You doing the cluster thing another day? I think that we've done enough of the cluster stuff for me to get a feel for what I want to do for the like histogram analysis. I think. We'll see. We will see. But I think that like, yeah, we'll see. What I was really hoping to get out of the clustering stuff was like a feel for strategies to deal with noisy data. And so I think that like the concepts have sunk in enough that I probably just won't go back to it. That's what I'm thinking, at least. That's the hope. Okay. What am I doing? We're trying to make a rect. So we don't, no, guys. We're not trying to make a rect. We are trying to make a rect. Don't twist my words, you guys. Canvas MDN render context. I want to see how to make a rectangle. We will be clear with our words. Make a what? Don't worry about it. Shh, shh, shh. Okay. So this is XY with height. Okay. So the X is going to be at this. And is XY top left corner? Starting point. Oh, we can just flip this. So we'll just make the Y value 0. And then we will go with width. And we will invert this to go up. Yeah. And we have to set the color somewhere. How do we do that? This. Okay. Maybe that's good enough. Could be. Doesn't look like it. What is happening? Like, is this just not fucking running? Like, what the fuck is going on? Request sub image, render histogram. Can we like refresh? Is this running? Like, hello? Oh, I have to. Oh, it's because I haven't done this yet. Okay. Why? Where's my histogram? Like, hello? Why is it just empty? Is this running? Console.log. Hello. Hello. It is running. So the histogram just isn't being built. Maybe this has to be positive. Okay, that's something. We're close. Oh, because we need to multiply the height by the height of the canvas. Oops. There we go. And then it looks like the height of this canvas is way too fucking big. Let's go 100. Okay. And then let's flip it. So the Y value starts at canvas.height, and this gets negatived. And then that should go up ways. There we go. I still... And the question is does this histogram change? No, because we're not clearing the context. So we need to, before we do anything, ctx clear, or fill rect from 0, 0 to canvas, width, canvas, height. And we want to set the fill style to white. Otherwise, we just keep things forever. Oops. Take the run, please. Like, why does it feel like that? Why is this bar always there? Like, everything else is fine, but like, what's special about that value? I feel like it's bugged. I guess we could look at the data and see if there's a consistent large number. 122 at 170. 142 at 170. $62 at 170. Haha, 0xAA? Oh, good eye. So have I just fucked something up? You think it's likely, with AA, it's likely that's just like uninitialized memory, huh? So we're looking over, oh! Image stride, maybe? Yeah. It's probably... No, because we allocated exactly the right amount. Oh, but our... Okay, hold on, let's go back here. So when we allocated this image... we probably, because of the box blur, have a border of uninitialized memory. Because we're not looking at the bottom left and top right corners. So probably we need to do something like start by initializing output. I guess we need our output to be a little bit smaller, is probably what we should do. So let's make our input image ROI. This is complicated. Complicated. Avril Lavigne, 2001. 2001? That's my guess. Oh, so close. So close. Okay. Here's what we do. We just make our output thing -1 here and -1 here. Anthony Fantano over here. But for like specifically for like angry girls in the year 2000, pretty much like there's only like it's just like a few bands. I didn't know very much music, but there was like a few bands that I was really into and I could just kind of guess what year that was. And funnily enough, Avril Lavigne's on it because on the Family Channel, which was Canada's version of the Disney Channel, there was a music video where she stood on a car, and I thought that was so fucking cool. So there's the vast majority of music I won't guess right. But man, like, whatever age, yeah, Skater Boy, yeah, I think it was, right? It was probably this. Mute. I'm gonna get banned. Right? She like jumps on a car here, yeah? Here? Are they like on the street? Yeah, right here. She's on the car. Anyways, it'll be in my head forever. Okay, and then we're trying to remove the border. So this is y -1 and x -1. And I guess this width and height is actually -2 because we have a 1 pixel border on each side. Well, it's like this, I think. Maybe. So he's mad for all sorts of reasons. Index out of bounds. Because this needs to be ROI width US -1 as well. -2. Gross. Gross. Memcopy arguments have non-equal lengths. Where is this memcopy happening? Memcopy. Oh, down here. Oh, because of the iterations of our box blur. Fuck me. Okay. Fine. We'll just copy the... We'll just initialize it with the value with the values, and we won't blur it, and that should be good enough because I don't want to do all this math anymore. It's too hard. Too hard, man. It's just too hard. Okay, let's see if that at least... There we go. That's a way more sane histogram. So if we look at only the like super dark segments, we see mostly dark. If we look at a bright segment, we see like something in here. If we look at an even brighter segment, we see something over here. Chillin'. Dude, the first thing I ever searched when I had my very first computer was Avril Lavigne. That's so funny. She was so cool. Okay. So now what I wanted to do was I wanted to like make an algorithm that like looks for peaks in the histogram. So first let's start by saying like, what if we like looked at an image of like this scale? Here we have pretty clear peaks here and here. And kind of what I'm thinking is I'm thinking that if we take like the highest peak here, if we were to like kind of sort the histogram by height, what we should end up seeing is we should end up seeing like here, here, and here are super valid, like interesting areas. And then I'm kind of thinking if we like expand, looking for how do I say this? Like if you were to like walk down the hill, basically just like keep on picking the next highest thing over and over and over again, there will be a point where like like your clusters will collide into each other, and maybe that provides something interesting. That's what I was thinking. So maybe what we do is we start by, yeah, let's make a little like how we want to say this. Let's store some sort of like histogram or cluster finder in here, which will be some sort of like cluster finder. And this is going to look at the histogram of the output image. So we're going to have like histogram here is 256 elements of usize. And we're going to have some sort of clusters in here as well. And these clusters are just going to be they're going to be like a 2D struct, I guess, right? You have clusters are array list of unmanaged, of array list unmanaged, 2D arrays, where this guy's element is going to be the index into the histogram. So usize equals histogram index. And we're going to store an allocator in here as well, which is going to be, we're actually going to store an arena in here so that I don't have to worry about like memory. Yep. I actually have to look into this. I don't know if like using an arena for something, it results in like heavy over allocation. I don't know if that happens, and I'm not going to find out if it happens because I'm feeling lazy, but it is something that I should look into at some point. So we have some clusters, and we want to, on dinit, basically clear the arena. Easy. Okay. So our cluster, we'll figure out what we're going to actually do with this stuff later, but we'll do this for now. Clusters is this. And on each iteration, we're going to do something, probably just some step. And in here also, we're going to store, like we want to sort the histogram by height, I think. That's what I'm feeling right now. And so we'll say sorted histogram buckets is going to be 256 usizes. And so this is going to be counts of pixels at given brightness. And this is index into histogram array. Just to be very clear about that. And so on initialization, maybe this should be like a stood array list of usize for now. Yep. And so on initialization, we're going to pass in some histogram, which is a bunch of usize. He's going to return himself. And he is going to have to do something we haven't figured out yet. But it's going to be like histogram is equal to histogram, easy. But he's going to want to sort the histogram bucket. So for histogram buckets, how do we do this? We just do first we start by making 256 elements that we rotate, or how do I say this? Just 256 elements. Great. So var sorted histogram buckets is equal to array list of usizes. We need to have some sort of allocator in here. Yep, that's fine. And we're going to initialize them with the allocator. And then we're going to store this allocator over here. No, we don't have to. It's fine. And we're just going to say for 0 to 256, sorted histogram buckets append I. Great. We init this with some capacity so that we don't fuck ourselves. Like, so that we don't have to, like, realloc over and over again. We just, like, we know the size up front, so we can just use that. No big deal. Uh-huh. And then we sort these guys according to some criteria. So we're going to use unstable sort because I don't really think that there's a reason to use stable sort. What's the difference even? I just feel like I never want stable sort. Means that the relative order of records with equal keys stays the same. Yeah, I really don't care. I really, really fucking don't care. And he's sorting elements of usize. With the items that he's sorting are sorted histogram buckets. And what's the next thing? Context? No context. And we need some sort of less than function. So we're going to say const less than is equal to some struct because there's no inline function in this language. And then we pull out the function here. Say pub function f is something. And I'm just going to pass f in here. And what's going to happen is it's not going to compile. It's going to tell me what the file type or the type should be. Well, if everything else compiled. But instead, what's going to happen is all of these other things that I did wrong are going to get in our way. Great. Shadowing. Disgusting. Disgusting. Okay, let's try it again. Histogram is equal to histogram like this. Missing field, cluster finder. Ugh. Can we just say like unreachable? Like I just want to come on, just give me something to work with. Tell me what I did wrong with sort PDQ. Fuck. Oh, here. Cluster finder is equal to cluster finder init with allocator, and I guess this is going to be undefined here. And then when we set ROI, we will initialize the cluster finder as well. With an allocator and our histogram. Something like that. Init with capacity has no member. There's no member init with capacity, really? Is it init capacity, not init with capacity? Yeah, it is. Expected 2 arguments found 1 because I have to tell it the capacity, of course. Expected type this, found error out of memory. What? What is it complaining about? Okay. Expected type cluster finder. Found error. Oh, oops. This is, dude, the errors get a little confusing here, but they're trying to say, hey, I want the return type to have an error type on it, not just be cluster finder. And then when I call init with cluster finder, I need to write try over here as well. Okay, here we go. This is what I was trying to get to, was that I wanted this function type. And I guess it's fine to eat this cost now, because it's important. Pub function f is this. Okay. So we're going to take in 2 usizes, and we actually do need some context. The context is going to be the histogram, which we can't name the same thing as either of the other histogram blocks because shadowing. So we'll just call it h. And this is going to be A and B. And then here we're going to pass in histogram as the context. And then here we can say, I guess here we should pass in ampersand histogram, and this should be a slice of usize. That way we're passing in the pointer instead of the full thing. And then we could say return HA is less than HB. There we go. Cool. And so now at this point, we should just be able to return the full thing. We should have everything we need. we have our clusters is a clusters init with some allocator, which we haven't implemented yet, but that's fine. And then sorted histogram buckets is equal to sorted histogram buckets. Okay. And we want the biggest bucket to be at the end, which is how this sort will work. So I think we're chilling there, and we just need to add a int function here. So this is going to take in some allocator and return a clusters. And the reason that we use unmanaged arrays here is because we want to create an arena, right? We want to say const arena is equal std heap arena allocator, and he's going to take in like the allocator that we want to use, right? Call it child alloc so that we don't get confused. And what happens now is we say like, hey, we have some allocator. If we were to do this, right, allocator, what we would end up happening is this allocator would be pointing to this arena that's on the stack, but it's the arena on the stack is going to move over here into like the return variable. And so we need to make sure that like the clusters are not holding on to an allocator that's pointing to invalid data. So we use this like unmanaged version, which just means like every time we use these clusters, we'll give you a new allocator, and it's like going to be the same one, but it's like the new one. It's not the one that we use on initialization, and that's fine. So we can say arena is equal to arena, and clusters is equal to std array list unmanaged, std array list unmanaged usize, like this. Boom. Sig build. I don't know what I expected. So this, I guess, takes in this. And type is not a function. So I think I need to write init here. Otherwise, we're chilling. Okay. So we haven't actually done anything very interesting yet. We've just kind of like initialized this cluster finder. And so I think what we're going to want to do is we're going to look at, on every iteration, we want to pop the like biggest histogram element. So we'll start with just going self sorted histogram elements pop or null. If so, we'll say const biggest bucket is equal to this, or else if there's no more to look at, we'll just return. And for now, let's just do clusters add to we'll make a new cluster. Cluster ID is equal to this. And then we'll immediately add to that cluster. So we'll just for now, just so that we can like visualize something, I just want to get moving. So we'll say const clusters add to cluster ID and biggest bucket. Right. Just for now. Just so we can start seeing the thing on the paper. Add to cluster. So we need to make a add cluster. And he's just going to be self.clusters.append. This has to maybe fail. It's going to be try. And here he's going to pass in his allocator probably. Hello, self clusters, self. Oh, self doesn't exist. That's why. So append takes in an allocator and item. And so here we just make a new std array list unmanaged of usizes, like this. And then we have add to cluster, which takes in a cluster ID and an elem. And this is just going to be self clusters items at cluster ID append using our allocator the element. Yeah. And then we need to hook up our server. We want to add like a little button that we can use to hit next on. So we're going to say, hey, somebody might hit, say, next. And we will respect them. We'll do something when they do that. which means that if we get a request for someone to do a next thing, we have to do something, which is going to be self app next. And then we're actually going to want to probably return the new histogram. No, they'll just ask for the histogram again. So here we can just say we have this like request respond with, what is it? We take in the content and our options. And here we say keep alive equal false, and otherwise we don't really give a fuck. I don't know if this keep alive false is necessary, actually. I've just been doing it out of habit because I'm used to keep alive's breaking shit. But maybe like the Zig HTTP server handles that okay. My idea for finding maximums. Iterate some windows of the histogram, pushing window max the hash map. Pushing window max the hash map. Like as the window max as the key. I think that makes sense. I think I get what you're saying. I think. I think that I want to do something about like I want to like automatically kind of like fall off and like merge in the middle. I'm trying to find something that will like kind of like group all of this in one thing and all of this in another. And that's I think I'm just gonna keep going with what I want to do because I'm in control here. You can't make me, but I'm not. I think what you're doing is I don't think what you're saying is wrong. I don't think. All right, pub function next. So all this guy's gonna do is going to call self clusterer finder next, which I guess we could just do here. Self app cluster finder next. Then we don't have to make this API. We just need to make sure that our cluster finder now has this guy as public. And this has to say self. Okay, and then we are also going to have to get some clusters. So we're going to color each of our histogram elements differently depending on what cluster he's in. Which means over here, we're going to have to say like clusters. And we're going to do something similar to what we did in the histogram where we're going to look at the clusters from the app. So it's going to be app.cluster_finder clusters. We are going to respond with some JSON, make a JSON writer. It's just that we're going to say for clusters items, we're going to look at our cluster. And for each cluster, we're going to begin a new array. And then for each element in that cluster, we are going to say, hey, could we write that ID over here? And there's probably all sorts of reasons that this isn't good, but we will work through the errors one by one at a time. Pop or null does not exist. Interesting. But it auto-completed. Oh, I forgot to put brackets, probably. Nice. No allocator and self-clusters, so that's here. It's self-arena.allocator, like this. Arena allocator. Boom. Basic build. Boom. No function allocator. Allocator. We need an A in there. We can spell. It's hard, but we can do it sometimes. 65. He's complaining that there's no way to error out of this next function, I guess. Which means on our server, when we call next, we need to write try. Expected use size found void at line 66. Right, so add cluster has to return what ID we just pushed. At 67, another error is ignored. Boom. Okay, we compile. And now we need to add a button here. So we'll just kind of like slap a button here. We'll say next. And we'll say next button. And in our JavaScript, we will say, hey, let's look at that button, which is called next. And on click, we're going to do something. And it's going to be update histogram. Yeah. I guess it's going to just be render histogram, actually. That already exists. And then on histogram render, we are just also going to look for the clusters. Clusters response, and we're going to have clusters data is from clusters response JSON. And I guess what we're going to do is we're going to, after we draw all the bars, we'll just redraw bars depending on the cluster. So for cluster, let I is equal to 0, I is less than clusters data length plus plus I. For J is less than the, I guess we have const clusters equal to clusters data I. We say cluster length. Okay. And then we're just gonna have to do this same thing. But we'll just make it red for now because I don't want to deal with this. Eventually we'll have to pick color. Actually, we'll do this now. We'll say const colors is equal to red, green, yellow, orange. All right. And we'll just pick from colors I. Percent colors length. There. Okay. There's no way this is going to work, but we can start. Okay, so that did nothing. We are getting the word hello, so this is running. Maybe we hit the debugger at here. Nothing. So clusters data is nothing. Why? Why? Oh, because we're not calling the next function. We are not calling next. So what we need to do is we need to, before we do all of this, fetch next. Boom. And then here, oops, then we call render histogram. And then here, our render histogram is actually going to be next. Oops. I don't need to rerun the server. I just refresh, grab, slap next. Slap next. Oh, okay. There's a red bar there. It's not what I expected. Next. Right? Like where clusters data, we do have values there. They're just not what I'm expecting. Or sorry, it's not rendering what I expect. So it's probably a bug here where it's like this X is supposed to be points J. No. Cluster J, like this. Yes. Yes. I'm pretty sure that's it. Play. Next. Okay. These are close. we're definitely getting some lines on tall items, but the height is not right. Because this is supposed to be data. Instead of at I, it's at points data at cluster J, like this, I think. Maybe. Next. Okay, yeah, that's really good. So we can at least see that the iteration seems to be working, right? We're seeing that every time I click next, we're getting the next highest item. And all that's left to do is I want to say that if it's within some distance of a cluster that already exists, then we'll just add it to the same cluster. And probably what I actually want is my clusters to have like ranges, right? I want to say that this cluster goes from this value to this value. So let's try that. So here it's going to look something like our clusters are probably actually not going to be a list of points anymore. What they're going to be is a list of ranges. So we're going to have something like min is a U size and max is a U size. And when we add to cluster, I guess first we're going to walk the clusters. Self clusters. And here we have a cluster. And we're going to say if our range is less than the cluster min. Here, we'll do cluster. Yeah. If biggest bucket is less than the cluster min, and biggest bucket is greater than cluster min minus epsilon, cluster min equals biggest bucket. And then we do the same thing for max. So this is max, and this is less than max plus epsilon. This resets the max value. And when we add a cluster, we're going to, I guess on each of these, we're going to return. And if we made it past all of these guys, then we need to add a new cluster. So we're going to add a cluster with the biggest bucket as its only item. And when we add cluster, we are going to take in an item. And we are going to append something like min equals item and max equals item. All right, that's making sense so far. These have to be fixed to cluster range like this. And then add to cluster no longer exists. Okay. Then in our server, when we respond with these guys, we now don't have this like cluster items to walk. But we do want to write two elements into the array, the min and the max. And certainly this won't compile. Certainly. Self clusters. This would be items maybe. eps doesn't exist, so we'll just set hard code that to like 4 or something for now. That'll be tuned at runtime later, but for now we just write that. 72. How come? Oh, I see. That's fine. Yep. No dereference needed there. I fucked up. Error is ignored on 83. There we go. And he's probably going to complain that the value is ignored as well, so we'll just ignore it. We don't need it. Okay. Next. Okay, let's increase the epsilon to like 10, just to see. Refresh. Next. Okay. We're doing something wrong here in our rendering on our index JavaScript. Also, there's some memory leak, and I should fix that. It's on set ROI. We initialize our histogram buckets, and we never deinitialize them. So let's do our app cleanup, because we can't have memory leaks. We can't let ourselves get away with that, you know? So, pub function dinit of our app is just going to call self cluster finder dinit, I guess. And our cluster finder needs to have some sort of dinit function. Takes in self as a cluster finder. He can't fail, and he has to call self clusters dinit and self sorted histogram buckets dinit. And that should fix our memory leaks. No, we're still missing some. Oh, because we never dinit the app. Main defer app dinit. Let's try that again. Refresh, select. Next. Control C. Still! Wow, we suck. It is... Oh, on set ROI, we are replacing the previous cluster finder without resetting. Which kind of means that this, like, reset, when we set it to undefined here, that's no longer, like, valid. So we need to do, like, ret cluster finder init with... let's just make him... Ugh. How do I deal with this? Ugh. I hate it. We'll just do this. This is wrong. I don't want to deal with this, so we'll just make a bool cluster finder valid. I don't want to... Cluster finder valid is a bool, and we'll just set it to false. And then down here, ret cluster finder valid equal true. This is bad, but it is how it is for now. Next. Control C. Still no bueno. But I think that there's less now. Now it's on this 154. We never free the output. I see. So on dinit here, we have to say self alloc free output image, which does not exist actually. Self.openImage.image. There we go. Next. Control C. Oh my god, we're so close. 155. Really? Why does he get leaked? We allocate him. We error free on one error. And then we assign him to the output image. And then on deinit, oh, if we overwrite him, we have to do the same shit. We have to do the same shit. Self alloc free output image. There we go. That'll do it. Okay. Next. Control C, no more memory leaks. And then we have to fix the JavaScript here where he's rendering the min and max here. And so we kind of have to do... This is going to come from cluster 0, and you're going to end up at cluster 1. And this is going to be less than or equal to. And then I think that does what I want it to do, actually. No, it does not. Can we look at what's going on? Wherever the fuck that is. Why is this not supposed to, like... I thought I was supposed to get logs when I do dumb shit in here. I don't know why that's not happening. But it's fucking annoying. It's fucking annoying. So cluster has 14 to 14. So when I step... Should he not be drawing something here? Oh, this should just be J now. And this should just be J now. That's probably it. Next. Play. Okay, play. Interesting. So here, it does look like I have 43 to 56. And I have duplicates inside that range, which is a problem. Which means that in our app, when we are trying to adjust our cluster, we can't create a cluster if this is within another one. So if biggest cluster is greater than cluster min, and biggest bucket is less than or equal to cluster max, we also return in this scenario. That way we shouldn't end up with clusters that have the same shit inside. There we go. Yeah, okay. So that's something. We might have to take a book, like what's it called? We might have to like look at DB scan again and like maybe try to do something like... So first of all, we need to smooth the histogram. 100%. We should be smoothing the histogram. And we should also probably be like walking the hill right off rip, right? If we find this point, we should be like, is the next point close to the same height? And if it is, then we should like drop down it. I'm surprised kind of. I thought that by blurring the image, we were kind of supposed to soften the histogram as well. But I guess that's just not the case, but that's okay. It's okay. I let myself go way longer than usual because I was having too much fun. I think we made a lot of progress today. This is very fun. Very fun. So we built our little debug visualizer. We can draw segments on here and get a blurred image on the right. The blurred image is a little bit... there's like a border around it that's not very blurred, but we'll have to deal with that later. This is kind of fun. And then we have something where the beginnings of a histogram isolator. So here, at the very least, we have a good example of this red section is clearly dark and this green section is clearly light. And this yellow section is probably... Oh, this is only the section. So if we did something like more samples, let's take a look at this. Like, that's pretty fucking sick. We're pretty clearly seeing something start to happen here. So yeah, pretty happy there. I think we'll stop now because we're at 3 hours instead of 2 hours, which is usually how long I try to go. But tomorrow we'll probably come back, and I think that what we're gonna do is some form of like histogram smoothing, right? Like if we try, if the sample size is small, then all of a sudden our histogram starts to become pretty noisy. We could look into something like a kernel density estimation, which basically kind of takes like a noisy set of data and turns it into like a nice clean line that we could look at. Maybe that's helpful, maybe it's not really sure. And then hopefully we can continue on with like binarization. But yeah, I think we'll call it there for today. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time. It's 5 o'clock Pacific time now, so 3 hours ago till now. Usually we try to end closer to 4, but I was just having too much fun, so we kind of let it scooch on a little bit. I think I said we'll be back tomorrow. I lied. I'm going to take tomorrow off, but we'll be back on Wednesday to continue on. There's a YouTube link and a GitHub link in the Twitch description, so which has like playlists of all of our projects. So there's like Rust operating systems, like 3D geometry stuff. There's Git GUI, diff tool, terminal emulator, neural network. There's like, whatever the fuck I feel like, that's what goes in there. So if you want to check any of that out, it's there. And if you're watching on YouTube, there should be a Twitch link in the YouTube description. And if you've made it this far, you're a good candidate for somebody who might want to swing by and say hi. Yeah, I think that's it. Thanks for watching, guys. I'll catch you on the next one. Bye.